This is a small demo of using agentic AI across the software development lifecycle: requirements, design, implementation, and testing using PostQode. Each stage produces a real file. Each file becomes the input to the next stage. Nothing gets carried forward just by conversation memory. It's all anchored in files you can open and read yourself. Before we start, one setup detail worth pointing out. These 5 prompts, the ones that take us from requirements through deployment, aren't typed fresh each time. They're saved in PostQode as workflows, reusable, named prompts you can invoke on demand instead of retyping or copy-pasting from a doc somewhere. That matters for 2 reasons. First, reliability. If a prompt is doing real work, pinning technical decisions, enforcing scope boundaries, we want to run the exact same wording every time, not a slightly remembered paraphrase. Saving it as a workflow guarantees that. Second, it mirrors something real about how teams actually adopt agentic AI. Instead of every engineer inventing their own ad hoc prompt for "generate a design doc," we want a small number of vetted, reviewed workflows that encode how the team wants requirements, design, implementation, and testing to be done, and then everyone just runs them. That's the same instinct behind checked-in lint configs or CI pipelines, just applied to how you prompt an agent. So as we go stage by stage, you'll see these invoked from the saved workflow list. Let's start with requirements. I am using the OpenAI GPT-5.3-Codex model get this demo. First stage requirements. This is plan mode, not agent mode, on purpose. Plan mode is built to reason and propose before anything gets built. It won't touch the file system or write code, it just thinks through the problem with you. That's exactly the posture we want for requirements gathering. Notice the prompt explicitly asks the model to ask clarifying questions, and to ask them all at once, in one message. Left unconstrained, some models will keep asking follow-up questions indefinitely. Bounding it to a single batch keeps this predictable. Here's the model asking about framework, storage, visual style, testing, deployment. Exactly the kinds of decisions a real requirements phase has to nail down before design can start. Instead of answering live, I'm pasting a prepared answer key. This is deliberate. It means every run of this demo, regardless of which questions the model happens to ask, gets pinned to the same underlying decisions. Framework is Flask. Input capped at 5,000 characters, no persistence, a fixed color palette, PyTest for testing, requirements.txt for dependencies. And here's the output, requirements.md. This is our single source of truth for what the app needs to do. Every later stage in this pipeline reads this file. It doesn't rely on remembering this conversation. Second stage design, still in plan mode. We're still not writing code, we're turning requirements into architecture. What routes exist, what the request and response look like, what the counting algorithm does, how ties get broken. One important detail here, the prompt asks for a resolved decisions section at the top of design.md that restates every constraint from requirements.md as fixed values. That's what turns our answer key from earlier into permanent, authoritative facts in a file, so implementation and testing don't have to guess or rederive anything. Here it is: framework, server binding, port, testing library, all locked in as plain text. This is the file every remaining stage will point back to. Now we switch modes. This is agent mode, and that switch is deliberate. Agent mode is the one that actually runs commands and edits code. It executes rather than just proposes. That's the right mode now, because this stage's job is to actually build something. Watch the tool calls here. You can see the agent creating files, writing the Flask routes, applying the visual style tokens from resolved decisions. This is the part of agentic AI that's genuinely doing work on the file system, not just generating text in a chat window. One thing worth pointing out, the prompt explicitly tells it not to write any tests here, even a quick sanity check. That's a scope fence. Without it, implementation agents might throw in a test file unprompted, which blurs the line between implementation and testing as separate SDLC stages. We want those kept distinct. And there's the app, running locally. Fourth stage testing. Still agent mode, since we're back to producing real files and running real commands, this time test files and a test run. Notice the constraint here. Every test has to follow a range, act, assert structure. one behavior per test, descriptive names. This isn't just about clean code, it's what makes the test suite genuinely readable afterward, useful documentation of what the app is actually guaranteed to do. First, it writes out a test plan in test-cases.md, covering the edge cases from requirements, empty input, oversized input, ties, non-UTF 8 characters. Then, it turns that plan into real PyTest test functions. And here's the test run itself, using the real app we just built. This is the validation stage of the SDLC. Does the implementation actually satisfy what the requirements promised? Last stage, deployment. Agent mode again, this time producing setup instructions rather than application code. Notice what this prompt explicitly rules out. No public tunneling, no hosting platforms, no production WSGI server. Just Flask's own built-in development server, run locally. That's a deliberate choice for this demo. It keeps the deployment story simple and dependency-free for anyone rerunning these prompts themselves later. And here's deploy.md, with start commands for both Unix shells and Windows PowerShell, since that's exactly the kind of detail that trips people up if it's left unstated. Let's also just try it by hand. This is a short paragraph about the classic Hello World program. Submit it, and we get the top words back, exactly the kind of behavior our test suite just verified automatically. So that's the lifecycle requirements: design, implementation, and test. Each one a file, each one read by the next stage. Plan mode for the thinking stages, agent mode for the doing stages. Nothing here depended on remembering a long conversation. It's all anchored in files you can open, read, and rerun yourself.